Hi, welcome to Fox News. My name is Michael Husid. Today we will be visiting colleagues at Seneca College. We will be discussing additive manufacturing, 3D printing, a new immersive technology that is stagnating, that is really taking over the future, so to speak. Today it's not really as feasible as one would hope for the average consumer, but maybe in the foreseeable future we will see more and more of this technology readily available for people looking to purchase them and for their homes.
Hello, my name is HWD Presentation. I'm the VP of R&D of 3D Printing Corporation. We are located at 70 University Drive in Toronto. I'll be discussing the application of 3D printing and the uses of it today, and how it's changing our modern technology. 3D printing is now used in many industries such as automotive, medical, and aerospace. The benefits of 3D printing usually comes down to a couple of factors, such as how long it takes to get the product to the market and to the people, and furthermore, for example, like time to market. 3D printing allows ideas to develop faster than ever these days in today's society. Being able to 3D print a concept the same day as it was designed is a huge jump in technology.
Good evening, sir. So could you tell me more about yourself?
Yeah, I'm Bimal. I'm the Chief Operational Manager in 3D Corporation. Today I'm going to discuss about what is 3D printing. 3D printing is a process of making two-dimensional solid objects from the digital file. The creation of 3D printing object is achieved using additive processes. In the additive processes, an object created by laying down successive layer of material until the object is created. Each of these layers can be seen as a thin sliced horizontal cross-section of the object.
So the premise of additive manufacturing, in the history of manufacturing, subtractive methods have often come first. The province of machining, generating exact shapes with high precision, was generally a subtractive affair, from filing and turning through milling and grinding. Additive manufacturing's earliest applications have been on the tool room end of the manufacturing spectrum. For example, rapid prototyping was one of the earliest additive variants, and its mission was to reduce the lead time and cost of developing prototypes of new parts of devices, which was earlier only done with subtractive tool room methods.
And it shrinks basically the development process from what might have been taking months to complete, which can be done within a matter of days, maybe even weeks. This is a step in the right direction to helping companies stay a step ahead of the competition. Since the product will be readier quicker and compared to the competition, they have a little bit a head point or a lead in the field. The second point will be saving money. Prototyping, injections, molds, tools, and production runs are expensive investments. The 3D printing process allows the creation of parts or tools through additive manufacturing at rates much lower than traditional machining. So it's a lot quicker to produce and make the product, and it'll be a lot cheaper at the end of the day to make it by using 3D printing.
So how does 3D printing actually work?
3D printing works by making the virtual design of object you want to create. The virtual design is a CAD file, which is computer-aided design. This CAD file is created using the 3D modeling application or with the 3D scanner. A 3D scanner can make a 3D digital copy of an object. 3D scanner uses different technology to generate the 3D models. For example, time of flight, structure, modulated line, volumetric scanning, and many more. Recently, companies like Microsoft and Google enable their hardware to perform the 3D scanning. For example, Microsoft Kinect. In the near future, digitalizing real objects into 3D models will become an easy as talking or as taking a picture. Full version of smartphone will probably have integrated 3D scanner.
So Bimal, could you please tell me about the 3D modeling software, please?
Okay, 3D modeling software basically it comes into different forms. There is the industrial grade software that costs thousands a year per license, but also free open source software like Blender. When you are a beginner and amount of choices are a bit of overwhelming, when you are the beginner and the amount of choices are a bit overwhelming, we recommend to start with Tinkercad. Tinkercad has the free version and it works in browser. For instance, like Google Chrome, they offer beginner lesson and has a built-in option to get your object printed through 3D printing services. When you have 3D model, The next step is to prepare it in order to make it 3D printable. From 3D model to 3D printer, you will have to prepare the 3D model before it is ready to be 3D printed. This is what they call slicing. Slicing is dividing a 3D model into hundreds or thousands of horizontal layers and need to be done with software. Sometimes a 3D model can be sliced from 3D modeling software application. It is also possible that you are forced to use the certain slice tool for the 3D printer. When the 3D model is sliced, you are ready to put it into your 3D printer.
However, as the years go by and technology continually advances, additive methods are moving even further into the production end of manufacturing. Parts that formerly were the sole province of subtractive methods can now, in some cases, be more profitable via additive ones. However, the real integration of the newer additive technology into commercial production is essentially a matter of complementing subtractive methods rather than displacing them entirely. Predictions for the future of commercial manufacturing starting from today already begun infancy period are the manufacturing firms will need to be flexible, ever improving users for all available technologies in order to remain competitive. The future of additive manufacturing is predicted by some additive manufacturing advocates that this technological development will change the nature of commerce because end users will be able to do much of their own manufacturing rather than engaging in trade to buy products from other people and corporations. So you would be able to buy your own printer and you'd be able to manufacture your own product, so to speak. 3D printers capable of outputting in color and multiple materials already exist and will continue to improve to a point where functional products will be able to be output. With effects on energy use, waste reduction, customization, product availability, medicine, art, construction, sciences, 3D printing will change the manufacturing world as we know it.
Mitigated risk. Being able to verify the design before investing in an expensive molding tool is worth its weight. So 3D printing allows you to basically prototype your product, look at it, and see what changes you might need to make in order to get the final product ready. So printing a production-ready prototype builds confidence before making these large investments. It is far cheaper to 3D print and test a prototype than redesign and alter an existing mold. And now I'd like to get into the examples in the fields where it is used. So for example, in the medical field, the modern dentistries rely heavily on the ability to produce small, complex components that fit inside our mouth. The use of 3D printing in the medical field can come down to anything, from amputations to dentistry, for example. Dentistry heavily relies on the ability to produce small, complex components that fit inside our mouth. Since everyone's mouth is a little bit unique and all adhering are unique, every set has to be unique basically, and the application has to be custom made, and 3D printing allows you to complete that task. Furthermore, the use of 3D printing of automatic in the design, it basically relies on forming the scale models that showcase the vehicle, which then can later be used to test the aerodynamics of the vehicle, which will save you a lot more money because the material used for 3D printing is a lot cheaper than using the actual molds, right? And they're often, these are accurate models that allow design intention to be clearly communicated and showcase the overall form and concept of the design for the final product. The use of 3D printing doesn't really have to heavily rely on industrial use, it also can be used for personal use. For example, playing a guitar and your pick breaks. What can you do? You can go buy one, or unless you have a 3D printer available, you can easily code one using CAD, which is CAD. It's a computer software that allows you to program the 3D printer to print you whatever you like. So you can print yourself a guitar pick, you can print yourself any type of mold that you want related to that or your musical needs. The downside of using a personal printer as a 3D printer comes down to the cost. The cost of a 3D printer is normally around $3,000, $4,000 for a home use. But industrial, if you're looking for those heavy type ones, come down to even close to $90,000 or $100K. So it's not widely available to the consumers as of right now, but as time progresses, it'll become more widely available and the use of 3D printers will expand.
Could be the sunset, or just the look in your eyes that shine so bright. Reach out over the ocean waves and try to come to life.